Okay. Well, hello everybody. I'm excited to be doing this first live stream. I guess we still have a few minutes before 30 after when I said we'd start, but I figured this is not a bad time to test the video and audio. Video looking okay? Give me a thumbs up or something in the chat. Let me know if you guys can see me okay. Everything's coming through all right. Well, so the plan for the day, welcome if you're joining us. The plan for the day is to go through a little bit of VLSM training. Hopefully most of you have seen the Subnet IPv4 videos or the Subnetting Mastery video playlist. If you have, go ahead and let me know in the chat room, just so I have an idea of where we're all starting. And what we're going to be doing today in this stream is essentially continuing where that live stream, where that video series ended. And so we'll run through a quick kind of review of what was covered in the Subnet IPv4 videos. And then from there, we'll just continue we'll dive right into some subnetting training. By the way, this is the first live stream I've ever done. Inevitably, there'll be some sort of technical difficulties. Just bear with me as we kind of work through it. For starters, every time I pop out the chat in the YouTube live stream video, it seems to crash on me. So I guess we'll do it this way then. Hey, Jeremy. Good to see you. Glad you could join. Okay, let's get to it. So I'm going to move my face off to the left over here. Okay, so if you've sat through the subnetting video series, then you've seen this slide. In this slide, we talked through how you can take a /24 network represented by this yellow box right there and break it up into a bunch of different size networks. On the example right now, you see a /25, a couple /27s, and a /26. We explained in the Subnetting Mastery video series that that's all subnetting is. It's taking one network and dividing it into subnetworks, into smaller networks. Then we walked through these 7 attributes of subnetting. We explained what each one of them are and showed you exactly how to solve for each of those using this cheat sheet. Now again, all of this was covered in the Subnetting Mastery video series, so this should all be a review. But in that series, we went through these steps and used this cheat sheet to be able to extract these 7 pieces of information from any IP address and subnet mask. Now in that series, I told you that every subnetting question you ever encounter is only going to be solving for one or more of these 7 attributes. You're going to see that proven again today as we do VLSM. In particular, the next network one is going to be very important. Cool, so I'm just checking on the chat over here. N19, the videos are at subnetipv4.com. Tien is complaining or mentioning that the video stream is pretty low. How's the video stream quality for the rest of you? You guys getting a decent stream? Go and mention something in the chat room if you could. Thanks, Jeremy. Tien, it might be something local. Cool. Awesome to hear. Yeah, Chen, it might be something local. In any case, if you haven't seen those videos, subnetipv4.com is where they're all posted. In those videos, so again, we use this cheat sheet, these steps to solve these 7 things. So after I showed you that, I showed you how to do it faster using these 4 speed tips, and that's what led us into our FLSM and VLSM discussions. First, we went through FLSM, which had us stepping through this illustration where we talked about how you can take one subnet and break it up into smaller subnets. And every time you do, you double the amount of networks, regardless of where you start. So we'll play that again just for kicks. If you start at /0, again, doubling that, going to /1s would go to 2/1s. If you start at /10s, going to /11s would get you 2/11s or 4/12s, and so on. We use that to answer these types of questions. Questions that essentially have you break up one network into many different networks that are all the same size. That's what makes this an FLSM question, fixed length subnet mask, because all those networks you break everything up into are all the same size. Finally, in the series, we ran through this illustration where we did a VLSM problem. With VLSM, we had a network topology that had a different requirements for a certain amount of IP addresses on each network. And then we broke up this /24 that they gave us, the 999.0/24 network, into appropriately sized blocks. And we used this neat visualization so we could see exactly which blocks were going to which particular networks. Now, the point of using this visualization was as an illustration tool to show you what VLSM problems are doing, what you're trying to do with a VLSM problem. I think it's a very effective way to teach VLSM, but in an actual Cisco exam or any other network certification exam, you're not going to have time to draw out a large chart like this to do VLSM problems. That's the point of today's training, is I'm going to show you how to do these types of problems using only a paper and pen or a scratch pad or whatever they give you for your exam. So hopefully that brings everybody up to speed with what we're going to be doing. If that's all sitting well with you guys, go ahead and mention something in chat. Give me a thumbs up or an emoji or something like that. Just let me know that you guys are still with me and everything's going good. Cool. It does look like the chat is further delayed than the actual live stream. Looks like the live stream is only 4 or 5 seconds and the chat is 15 seconds. So I guess that's something I'll have to get used to it or figure out in the future. In any case, let's get right into it. So I have a couple things already kind of prepped for us. That's this whiteboard session right here. So on this whiteboard session, we've got the cheat sheet because we're going to make use of that. And again, if you are unfamiliar with the cheat sheet, you can draw it out. We showed you that in video 2 of the Subnetting Mastery video series. And then we have this topology. Now it's the same topology we were using in the Subnet Mastery video series, but honestly the topology is pretty arbitrary. We're going to use the topology right here just because it already exists, but it doesn't really matter what it looks like. And you'll notice this, and you'll see this rather, because the next problem we do together is not going to have a topology at all. But this will help us kind of ground the concepts in what we already know, or at least that's the plan. Now, just to prove to you that this isn't a pre-built scenario or anything like that, I have put together a little script that just generates random numbers, right? I don't know what numbers are going to come up from this, right? And I can show you guys the code for the script. It's just a little bash script, nothing too special. Get rid of this guy. But the point is, I have no idea what this is going to be doing or what this is going to generate. And we're going to use these random numbers, in fact, in a random order. We're going to use these random numbers to solve a new VLSM problem that you or I or no one else has ever seen before. And I'm going to do this to kind of show you the steps required to solve VLSM quickly and easy. So this looks like let's do another one. Sorry, look perfect. This looks like a good place to start. So we're going to solve VLSM for these 6 networks as the 6 networks that belong on this, or rather, not networks, as the 6 number of required IP addresses we're going to need in each one of these subnetworks. Meaning, this network right here is going to need 4 IP addresses. The next one down is going to need 15 IP addresses. The next one is going to need 25. The next one's going to need 11, and then 62, and then 14. And again, I'm just picking them from what we have over here. And these are all randomly generated. So again, I've never seen this before. This isn't something I've pre-scripted or whatever the case. We are still going to be using the 9.9.9.0/24 network. But again, the IP addresses you start with is largely arbitrary. You'll see that the rules we discuss sort of apply regardless of what you start with. Okay, so with that said, in the videos, I told you guys the first step you should do when you're doing VLSM problems is to figure out the appropriate size network you need for every network size that you've been given. So for us, we were given 6 different network sizes. And what we're going to start by doing is figuring out what size network we need for each of those networks. So if you watch the Subnetting Mastery video series, you know that this chart has 3 lines, and the first line is essentially going to tell you the number of IP addresses in each size network. And so we can use that to quickly determine what size we need to assign to each of those. We'll do that in pink. So for this network right here, I need 4 IP addresses. Now, it might be tempting to be like, okay, cool, there's a 4 right there, a /30 is 4 IP addresses. But remember, this first row rather, is showing you 4 total IP addresses, not 4 usable IP addresses. To get the usable IP addresses, you have to subtract by 2. So while this has given us 4 total IP addresses, it's only 2 usable addresses, so a /30 will not work for that network right there. Instead, we'll use a /29, which gives us a total of 8 addresses, or 6 usable addresses, which is going to be enough for this first network. And then what we just did, we'll just do again for all the other networks in our VLSM problem. So over here for 15, again, it's tempting to just look at that 16 to determine that, oh, that's going to be big enough. But again, we have to account for the -2 in the usable addresses. So for that guy, we're actually going to need to assign a /27. For this guy, we need 25 IP addresses. 32 gives us 30 usable IP addresses, so we can still use a /27 for that guy. And then Derek, to answer your question, yes, this is going to be recorded. I'll be posting this to my Discord server sometime the next day or 2, if you want to see what you missed. Cool. So for that guy, we need 11. Clean this up a little bit. That would be enough for 11, giving us a /28 for that network. For 62, a /26 gives us 64 total IP addresses, or 62 usable, so it is just barely enough. We'll make that a /26. And then for 14 down there, this guy will again be enough. So that will be a /28. So that takes care of kind of the first step of any VLSM problems. It's essentially assigning out what size network you're going to need for every single network in your topology, based upon the requirements provided by the question insofar as how many IP addresses you need on each network, which for us, we just picked out randomly. Now, so far, let me check in with you all in the chat. Is everything sitting well with you guys so far? If so, say something in the chat, or a thumbs up, or an emoji, or whatever. Cool. Cool, cool, cool. Thanks, Daryl, for the literal interpretation. I like it. Okay. Now, as you guys can see, my handwriting on the screen is not amazing. So what I'm going to do is use this notepad box over here to give our final answers. And what we've to do so far is that this first network is going to be a /29. This network, I guess the second one down from the top is going to be a /27. This third one is going to be a /27 also. This guy, let's go one here. That guy's going to be a /28. That guy's going to be a /26. And this guy's going to be a /28. So all we've done is we've taken what we did before, and then we've just kind of wrote them down as our little answer sheet and notepad, so it's a little bit more legible. Cool. So now the second part of VLSM questions is actually assigning out IP address blocks to accommodate for the size of networks that we need based upon what we just did. And this is the part where we go back to the 7 attributes of subnetting, in particular using the next network field. So let's do this. So we'll start over here. We were given the 9.9.9.0/24 network. So I'm going to write that right here at the top. I know the first network I assign is going to start with 9.9.9.0. I just need to figure out the proper increments to account for all the other networks on this list. Now, the way to solve these is by starting from largest to smallest. So here, the largest network in our topology is going to be this guy right here, our /26. Well, if we look at our subnetting cheat sheet, we know that a /26 has an increment of 64, which means if I was trying to break up my 9.9.9.0/24 network into /26s, I would go in sets of 64. So the first jump would take me to 64. The next jump would take me to 128, and the next one would take me to 160. Wow, math fail. 162. That's not right at all. 192. Now, that would work. That would work if we were trying to break it up into, just sets of 4 /26s. But we only need 1 /26 to account for this problem. So really, I didn't need to go this far. This is going to be the /26 network that I'm going to assign to that network. So it's going to be this guy right here, 9.9.9.0/26. But if you recall from the Subnetting Mastery videos, the increment after your starting point is the next network. So this right here is the net ID that I'm using, and then the next value, .64, is the next network. What that means is the next size network, if it's a /26 or smaller, is going to start on .64. So I can use that as my starting point for what's next. So let's do that in a different color. Oops, that's not the eraser. So after my /26, the next size network, insofar as biggest to smallest, would be the 2 /27s right here. It's convenient that they're right next to each other. If we look at our chart, a /27 has an increment of 32, which means I can start from this guy right here in sets of 32. So .64, then .96 to .128, if I did the math right. These two net IDs that I have the arrow pointing to are the net IDs for these two /27s. And this guy, 128, is the next network that I'll be starting from going forward. So we can fill in our answer sheet over here, 9.9.9.64 and 9.9.9.96. And where we start next is going to be on the 128. So let me check in with you all, make sure everything is tracking so well, tracking so far. Go and let me know in the chat if everything is going okay, and I will spend that time cleaning up the picture a little bit. Cool. Cool. If there's any questions, definitely just throw them out into the chat, and I'll grab them in these pulse checks. I think going forward, if I'm going to do these live streams, I'd love to find a quicker way to interact with the audience. So I might have to look into that, but that's another story. Cool. So we're just going to continue with the same pattern. We've left off at 128. We've taken care of assigning network IDs for these two /27s and this /26. So the next size network, if you continue on from biggest to smallest, will be our /28s. And again, there's 2 of them. So that's them right there. And if we look at our chart, a /28 has an increment of 16. And I'm just going to continue from 128 in sets of 16. So our first network ID for a /28 will be that guy right there. Our next one is going to be 144, if I did the math right. That would actually give me the network ID for both /28s. But again, I have to solve the next network to know where I'm going to start going forward. So I have to go one more. 144 plus 16 would get us 160. That right there is the next network that I'll be starting from. And I can now fill in two more answers for my answer sheet. 9.9.9.128 and 9.9.9.144. Cool. So we've solved these three networks so far and these two networks so far. We have one left. Now that guy is a /29, which gives us an increment of 8. So let's go ahead and clean up our topology a little bit and do the last guy in our list. What color haven't I used? This guy. We're on that guy. We're going to start from over here. The increment of 8 would mean that the next network would be 168. And if there were more networks to solve for in this topology, that's where I'd be starting from. But for now, since this is the last one on our list, we can fill that guy in as the answer for our /29. So that right there is essentially how you would solve for the next network how would you solve VLSM problems without having to create that huge chart that we did in the illustration videos. All you really need is the cheat sheet and solving for the next network sequentially from biggest to smallest. Now, we could continue from here. Notice we have two point-to-point links. Those two point-to-point links need two IP addresses. Presumably, one of them is for the IP address on R1, rather on this link. One of them is for the IP address on R1, and the other one is for this IP address on R2. And then for this link, it's again the IP address on R1 and the IP address on R3, rather. So again, we can continue the same pattern we've been using. Now, depending on what school of thought you're using, if you're taking a kind of beginner level or CCNA level certification, they will say that the smallest size network you can assign on a point-to-point link is a /30. That gives you a total of 4 IP addresses. And if you do -2, that gives you 2 usable IP addresses. Alternatively, there is an RFC, however, that does authorize the use of /31s. Pardon me. That does authorize the use of /31s for point-to-point networks. And so if you're using that school of thought, then the increment you're going to be using is 2. Or if you're doing the slightly more legacy school of thought, the increment you'll be using will be 4. One way or another, your final 2 networks are going to be either .168, again starting from here, or .172 if your school of thought is the /30, if you're doing /30s for those point-to-points, or if you're doing /31s for those point-to-points, your network ID for both of those is going to be 168 and 170. Again, just simply following the increment of 2 or 4, depending on what size you're using. Yeah, great. Chun asked a great question, is if we have to add more IP addresses later. It's actually not a super trivial thing to do. That's why you want to account for growth when you're assigning out IP addresses if you're designing a VLSM scheme in a topology. But if you had to add, say, more IP addresses over here to this guy over here, you would have to change this /26 into something bigger, potentially a /25. But in this particular instance, you've used the IP addresses that would exist in the first /25, so you'd have to kind of play some fun games with IP address carving, or potentially use a different IP block entirely. So not trivial, but doable. That's one of the benefits of IPv6, in fact, is that every single network is going to be so big, you'll never have to later expand an IPv6 subnet, because there's, what is it, like 18 quintillion addresses in every single IPv6 network. Cool. So that is the strategy for doing VLSM using just scratch paper. So let me check in with you all again in the chat room. Let me know how this worked out. If this all sat well, if you understand how I got to these values, I don't know, say something in the chat room. Thank you, Musa. Thank you, Cal. It's going to be a competition for who can take my words more literal than the last person. I like it. Absolutely, yeah. We're going to do one more, and we're going to do it even less graphical than this one. Okay. So it doesn't look like any questions have popped up, so let's go ahead and do one more. So here's another whiteboard with just a cheat sheet. And again, in the Subnetting Mastery video series, I show you how to draw this cheat sheet out super quick. So having just a whiteboard and this cheat sheet is probably going to be a good starting point for a lot of your exam-based subnetting questions. So we're going to go ahead and do it again. But let's actually have you guys tell us the size of, the number of IP addresses in each network we need. So go ahead and throw some random numbers into the chat room, anywhere between 1 and 100, we'll say. Let's get 5 to 6 of them from what you guys pick, and then we'll go from there. I'll start typing this out. Maya suggests 78. Let's go with that. Again, there's no wrong answer. Just throw a random number into the chat room. Somehow I knew that one would come up, Cal. $150 might be too big for our example, so we're just going to go with 50. Hi, Black Ice Bass. It's just the one that's on my laptop. I have an Asus laptop. Hi, Synth. Welcome. Cool. So that should be enough. Let's make sure. Let me do some quick mental math. Let's do one more. And we're going to make this guy actually, no, I think that's fine. We'll just do this guy. Okay. So again, when you're doing subnetting questions, often you're going to get a random set of a random topology or a random text that's going to say something like, hey, here are a bunch of networks. We need you to give us IP address blocks to use for, network A needs 78 hosts. Network B needs 69 hosts. Network C needs 35 hosts. Network D needs 50 hosts, and so on. We could literally continue for whatever the requirements are, but one way or another, the process that we're going to follow is going to be the same. Why is there that blue bar? Okay, cool. So let's simply start from the same starting point just as before. We're again going to start at 9.9.9.0. But again, the starting point is largely arbitrary. We could pick any other number that the problem would give us. We're just going to go with 999.0 for simplicity. And just like before, we're again going to use this cheat sheet to figure out the size of network we're going to need for each of the networks in our, we'll call it homework assignment or VLSM problem. So let me do that. And we'll start top to bottom. So for network A, I need 78 IP addresses. 64 a slash 26 is not going to be big enough, so I have to go over here to a slash 25. So that's going to be a slash 25. For network B, again, 69 slash 26 is not going to be big enough, so that's going to have to be also a slash 25. For 35, I would have to get a slash 26. For 50, again, it'd be a slash 26. For 17, I would have to do a slash, did it really go top to bottom? Yeah, we did, didn't we? Yeah, 2 slash 27s. So that kind of works out. It just slowly got smaller as we went. Yeah, I'm good with that. Let's do it. Cool. So right off the bat, and again, we're going to go from biggest to smallest, which means we're solving for network A and B first. Right off the bat, I know that one of them, the network ID is going to be the starting point. So since we have a starting point of 999.0, we know for a fact that the first slash 25, the biggest network we're going to assign, is going to start there as well. But we need 2 slash 25s for our problem. So again, slash 25 is right there. The increment is 128. So let me actually go move this a little bit. There. So this is going to be our first network ID. This is going to be our next network ID for a slash 25. But again, you have to go one more so you know what the next network is going to be. And now the next network for this guy is going to end in .0 in the 4th octet. But since we had to reset the 4th octet to .0, we actually have to increase the 3rd octet. So if we bring down all these values, you'll actually see what I mean by that. This 3rd value that I've listed is the next network after 9.9.9.128. I should say the 3rd slash 25 network after 9.99.128. It goes to 9.9.10.0. Now again, we picked that process and why that happens apart in the Subnetting Mastery video series. So if that's unfamiliar to you, check out, I believe video 4 is the one where we do problem examples. And I believe it's the last, it's the example number 3 or number 4 where we show you what's going on with this. In any case, this gives us the answers we are looking for. We know that our first slash 25 is 9.9.9.0 slash 25, and our next slash 25 is going to be 9.9.9.128 slash 25. Yeah, we'll do this for spacing purposes. Cool. So next we have 2 slash 26s to solve for. And just like before, we will look at the cheat sheet to figure out that a slash 26 has an increment of 64, which means that the next, so this is going to be our first slash 26. The next slash 26, oops. The next slash 26 is going to be where we started, plus 64. And then the one after that to solve for the next network is going to be 128. But this does give us the 2 network IDs we need for network C and network D. Which then brings us to our 2 slash 27s. And just like before, a slash 27, so let me clean this up a little bit. Slash 27 puts us right there with an increment of 32. And we're going to start from here and go in increments of 32. So .128 plus 32 would get us 160. And again, I'll bring down this 3rd octet, that's 10.160. That gives us our second network ID. And honestly, at this point, since I know the problem only asks us for 2 more, I would just stop right here, knowing that these 2 are the last 2 answers we need. If I needed to solve for more networks, I would obviously need to figure out the next network as well, which would bring us to 192 if I did the math on that right. either way, we have our answer. So we've got 9.9.9, rather .10.128, and 9.9.10.160. And then right there, we just solved another VLSM problem that we essentially put together ourselves. Yeah, so that's the strategy. That's how you can use the same cheat sheet that I showed you in the Subnetting Mastery video series to solve for any VLSM problem that you have using only scratch paper and pen. Hopefully that was helpful for you in kind of further landing the plane with subnetting. I know that subnetting, especially at first, can be a huge burden to try and understand. It's kind of a strange way of doing math, but after a few reps and hopefully watching the series, that will kind of get you through that hurdle. Okay, so with that, I'm going to turn it to chat. Any questions regarding what we just did or subnetting in general, go ahead and mention them in chat, and then we'll see what we want to do. We can either do more of these, or we can do a subnetting aggregation walkthrough, I guess we'll call it. I'm playing with all the different options you have for where my face shows up on the live stream. And I've got that's why I'm looking off to the side. This is where my chat is. It's off to my right. So we have one request for one more VLSM problem. Is that what people want to see? Looks like yes. So let's go ahead and do one final problem. Now, just for speed sake, I'll go ahead and use this script. Oops. And we will. Okay. So we definitely can go bigger, Musa. I'll say in Cisco exams, you probably won't do too many VLSM problems that require, you know, tens of thousands of addresses in a single single subnet. If you're just talking about how to subnet a /16 or /15 or /22 or something like that, the video series teaches all those in videos 6 and 7. So I would definitely recommend checking that out. And again, subnetipv4.com. For our purposes, we will stick with, tell you what, we'll pick random numbers from both of these. Okay, let's see. I'm just going to retype this. So we're going to go A needs 12 IP addresses, B needs 4 IP addresses, C needs 17 IP addresses, D needs 43, E needs 32, F needs, not 12 again, 29, CDFG, and network G needs, what number haven't I used from the random for? 19, looks like. Yeah, so our last one is going to be a total of 7 different networks with this amount of required IP addresses per network. And again, just like before, we're simply going to step through it all using this exact same cheat sheet. So I'll erase everything we have so far, and we will get right to it. And again, we will start just because it's worked for us so far, at the 9.9.9.0 network. I'll try and be a little bit neater. Cool. So stepping through this, our first step is going to be assigning out what size network I'm going to need to accommodate for every single one of these networks. Now, this doesn't have to necessarily go biggest to smallest. It doesn't really matter because the order doesn't actually affect anything when you're just assigning out network sizes. So we'll just go top to bottom. For 12 IP addresses, a /28 would be enough. So we'd go /28. For 4 IP addresses, a /29 would do it. So /29, oops, /29. For 17 IP addresses, that's not enough. We would need a /27. For 43 IP addresses, a /26 would work. 26. For 32, we would also need a /26. And again, all I'm doing is looking at this top column to see where there's a number that's bigger than what I need, and then obviously accounting for usable IP addresses versus total IP addresses. That's why for network E over here, I didn't assign a /27 because again, a /27 is 32 total addresses and 30 usable addresses. But 29 IP addresses can absolutely work for a /27 rather. I almost said /37. And then for network G, 19 IP addresses would also be a /27. Yeah, that'll work. I'm trying to think if there's anything else we want to do with it. Yep, we're good with it. Okay, so that's what we're trying to solve. See me, see the whiteboard. Awesome. And again, we will do it just like we have before. I'll take this and go there. Okay, so our biggest one is going to be what, these /26s right here, and I need 2 of them. And if we look at our table, /26 increment of 64, this right there is going to be our first one. Our next one is going to be on .64, and then we're going to solve for one more, so we have our next network for where we're going to start next. So our answers right away, we know for these two are going to be 9.9.9.0 /26 and 9.9.9.64 /26. From there, the next biggest one would be, nope, sorry. Oh no, the 3 /27s over here. So we'll pick a different marker. The /27 has an increment of 32, and I need 3 of them. So there's my first, there's my second, there's my third, and then again I need to solve for the next network. So I would go one more. 32 plus 198 was 224. Somebody double check the math on that. Make sure I got that right. But that is my answer for the next 3. And again, the order in which I assign these is largely arbitrary. You know, whether I gave this guy the 128 and this guy the 160 or vice versa, it's kind of all the same. 160 and then 9.9.9.192. Then I've got a /28 as my next biggest. Another color for that, a /28. The increment is 16. That is going to be the network ID, but the next network is going to be 240. So we can fill in our /28 rather, which is going to be 224. And now that that's our next network right there. And now that we only have one left, there's not even really a need to figure out the increment for a /29 and so forth. We know this is going to be the network ID of our next starting point. So I can right away fill that guy in, and we have just now completed another 7. Now, that one right there, I didn't have the timing exactly. I didn't start a stopwatch or anything like that, but I think it only took us 2 to 3 minutes, and that was still while explaining what I was doing. If you run through this process a few more times, you can get to where you're solving even somewhat complex VLSM problems like this in still 60 seconds. But that's the method. That's the method that I wanted to show you guys. And that actually also wraps up everything I had in mind to do for this stream and test out the live stream setup. I think it went all right. I'll have to figure out a better way to interact with the audience than YouTube chat. It's unfortunate about that delay, but I think there's some software you can get where you guys can like click along with me and stuff like that, and I think that's a little bit quicker response time. But before I end the stream, a couple things I want to let you guys know. I'm going to hang out in the Discord for the next 30 minutes to an hour or so. If anybody has any other questions about anything networking related, which is not to say I know everything network related, but whatever it is that I do know, I'd be happy to help and share what I can. If you're studying for the CCNA, definitely hang out. Definitely hang out in the Discord, and you know, I'm sure good stuff will come up. The link to the Discord, let me put that guy back up, is right there. Oops. There. You should see the link to the Discord. Am I pointing the right way? Nope, pointing the wrong way. Right over this direction. But definitely come hang out. I'll answer any questions for the next 30 minutes to an hour, kind of as long as the questions are going. If we need in the Discord, I can do a screen share and we can whiteboard some stuff or show you guys different stuff if necessary. And then the second thing, if you guys have been following with my blog or anything like that, you guys will know that I just finished recording a course on TLS and SSL. It taken me about 6 months to create this course, but it's a really high quality course, and we go in super depth on those protocols. So if you're interested in network security, cryptography, or SSL and TLS, which are the protocols that make the internet safe, you could say, definitely check out that course. I believe I left my early reviewer access link up, so feel free to check it out and take advantage of that. There's a pretty hefty discount that I had up for students who are going to join before the course completed. The course is complete, but I still have that discount code up. I haven't taken it down yet, so feel free to take advantage of that at my website, pracnet.net or practicalnetworking.net. But I think that's it. That's all I had. Let me do a quick scan of the chat, make sure there's no other questions. Noted about Twitch. Thanks. I will look into that. The TLS content is well beyond CCNA. Some of that stuff is a little bit CCNA related, but it's probably much deeper than CCNA. This would be more engineering level and mastery level for SSL and TLS. Jeremy, in fact, is actually in the course, and so you can take his word for it. Thanks, Jeremy. I'm glad you're enjoying it. Jeremy is actually one of the testimonials I've got on my course sign-up page, as it were. By the way, if you guys haven't come across Jeremy's content before, he has a free video training that covers 90% of the CCNA curriculum, and I think he's planning to finish that. Jeremy, if you want to fill in with the chat, I think you're finishing that in the next month or so, right? So it's about done. But definitely check out his CCNA course. It's almost frustrating because I wish I had resources like that when I first took my CCNA, like 12 years ago or 15 years ago or whenever that was. But definitely check out. Okay, a couple months, Jeremy says. Cool. Oh no, the Discord link has expired. Well, hang out. I will find a new link for you in the chat. Let me see if I can do that real quick. Actually, I can't without disabling the video. I'm going to hang out in the chat for a few minutes to give you guys the Discord link. And I guess that's it. That kind of wraps up our stream. Yeah, well, thank you guys so much for joining. Hope you guys found a lot of good stuff from there. Hopefully this was useful for you and will help out with VLSM going forward. Again, hang out for a minute. I'll get you guys the new Discord link in the chat in a second, and I'll be hanging out in my Discord for at least the next 30 minutes to an hour to answer questions or Q&A or do whatever it is you guys want. Otherwise, thanks a bunch for joining. And yeah, I guess we'll catch you guys in the next video. Thanks, guys.